First, I thought I would just very briefly set a little context for who the SEI is and what SEI does, because it's relevant to the perspective that I will be discussing. SEI is a federally funded research and development center. In essence, SEI is a DoD R&D laboratory. It's administered by Carnegie Mellon University, and it's headquartered in Pittsburgh. The distinctive competencies for SEI include software engineering and research, cybersecurity, emerging software technologies, as well as DoD acquisition solutions. The SEI advances research in software engineering and cyber technologies for its various stakeholders, which includes many DoD or many government customers, including DoD and the Department of Homeland Security, as well as researchers, developers, users, and acquirers in government, in the defense industrial base, commercial industry, as well as academia. So, given that that's the SEI's mission, I was asked to discuss big data implications in DoD, in government, in these mission-critical communities or mission-critical systems. From a lot of the discussions today, big data conjures up these images of large volumes of data, but if we look behind that number crunching, we know that there's a number of considerations that we heard about today. One is the whole data collection process, and as we think about these mission-critical systems, for many of them, there are sensors that need to collect a lot of this data. It's also about the infrastructure and the analytical requirements to leverage the variety of data sources. Another important consideration is the deliverance of decisions or predictions, but within very specific time constraints. And then there's a whole host of issues involving communications, algorithms, and storage requirements. So as you might guess, the U.S. Department of Defense, big data is very, very important to them. And they've established an initiative that's called Data to Decisions. And they're investing $250 million annually across various military departments in a series of programs that are designed to do two primary things: harnessing and utilizing the massive data in new ways and bringing together the sensing, the perception, and the decision support to make autonomous systems that can maneuver and make decisions on their own. So, for example, the Navy's working on these autonomous boats that know sort of the rules of the road. And then you've probably recently heard on the news, there was also the landing last week of a drone on the aircraft carrier. But these kinds of systems have to possess a high volume of sensor data. They have to process a high volume of sensor data in real time to maneuver and be able to make these kinds of decisions. Another primary focus is improving what is referred to as the situational awareness to help warfighters and analysts and provide increased support to missions and to the various operations. The U.S. Department of Defense here is looking for the ability for analysts to be able to extract information from texts that are in any language, and a similar increase in the number of objects, the activities, and events that an analyst can observe. So, for example, when you think about the growing volume of data that can be extracted from social media and the internet for intelligence and reconnaissance, that's a lot of data that we're talking about there. So the use of Twitter feeds and analysis of other social media to identify hotspots in large gatherings is also an area that the SEI is looking at. All of this requires high-speed networks, high-performance computing, fast algorithms, and efficient data representations, and all must be available at the tactical edge. So that's another sort of need and requirement that we're faced with. This creates architectural challenges and demands that change as quickly as technology changes. Paul said in his keynote this morning that this is all about having insights you never had before. And that's what the whole DoD focus is when you think about big data analytics. So these are some of the needs, but what are some of the challenges, and what is SEI doing about them, and what's Carnegie Mellon doing about them? Well, some of the key areas of research for us include anomaly detection in these massive data sets, developing novel approaches to detect activities consistent with cyber espionage and military computer networks. When you think about this, the network traffic generates massive amounts of data. So identifying these anomalous patterns in network data can indicate that there's a cyber attack or that there's an insider threat. Addressing various kinds of data quality issues, and also questions, and I think we heard about these earlier today, what data to retain and how long to retain data. There's also a number of mathematical challenges that we're facing, extracting insights from huge scientific data sets and finding the key features and understanding the relationship between these features. And then there's all the data mining kinds of issues where we're looking for clues without explicit theory to guide the analysis or interpretation. And Isa mentioned that what we're doing is looking for the hidden patterns in the data, and that's a lot of what's involved here. And then there's also the issue of validating the results. So how do we know that the algorithms are working in these tactical settings? And we can, the replay can be used, but it requires massive data capture. So think of replaying, for example, the stock market when there are millions of transactions and high-frequency trading happening with the significant metadata associated with each. Establishing effective and appropriate kill switches, for example, for the markets is a big question that's involving real-time prediction. And then finally, there's an overall reference to architecture and the architectural issues that are present here. We've got to understand rapidly the COTS, the GOTS, the FOSS components, and how they fit together to create sort of the end-to-end solution. We need to understand what trade-offs have to be made and how to identify the commonalities and reuse opportunities to the various programs. So this is a part of the DoD and the mission-critical environment that we're looking at. Just very quickly, some of the untapped opportunities, leveraging information to be able to do predictive analytics, and then engaging applied mathematics, computer science, and data visualization communities to develop the analytics and some of the usability kinds of solutions, and then being able to extract some of the useful knowledge from these huge databases requires smart and scalable analytics, various kinds of programming tools, and various kinds of applications. So that's some of the thinking around the DoD environment.
Thank you.
Yep.
Michael?
Thanks. My name is Michiel van Genuchten. The last 5 years I worked in the healthcare industry in Switzerland, and I recently moved back to the Netherlands. I'm a Dutch native. I would like first talk about, I think, a positive example of data mining, and then I want to talk a little bit about privacy. And you can imagine in healthcare there's some specific issues. To start on the positive note, over the last years, I was working in a company that supplied software to medical professionals. And like many software suppliers in the world, we did not know a lot about how that software was actually used. Like which features do people use the most? Also the question, hey, we're now bringing out a new release. Is that beneficial for our users? We have some ideas about it and we would like to charge them for the new release, but whether they really benefit from it is often less clear. And one kind of data mining, or some say it's a child, some say it's a sibling of data mining, it's called process mining. If you want to know more, there's a website, processmining.org, and there's an IEEE task force on process mining. And the basic idea there is you can ask people what process they follow, but there's so many computers, devices around that log all kind of events. You can also just go to the log files and use the log files to recreate the processes. And then you know how people are using your software. And so a very positive and interesting experience I had in that project was we were able, we brought out a new release of the software. We were able to go to some early adopters and compare 900 use cases, 900 cases where they use the old software versus 500 where they use the new software. And we could just learn and show the users that they were 11% more efficient. I think that is a positive and simple example, and something that can be applied broader in the software community, by the way. It's an interesting question you can ask yourself as a software supplier. Can we prove that the next release is worth the upgrade for the end user? And this is a way to find and figure it out. When you're in the healthcare domain, of course, when you start talking about medical data of patients, you have to start to be very careful. I really appreciate many of the presentations today, but the one after the break. For example, there's a law in Europe. It's not allowed to bring medical data of EU citizens outside of the EU. And it's happening often. And not only by people who like to share data around the world, but for example, you do a scan of a patient in Europe and you bring the data somewhere else in the world to maybe to convert or analyze the scan and send it back. That is happening. And it's also the combination with all kind of other with other data sources, and also the additional sensors that come into the world. A really interesting example, I don't know whether you heard of it's called it's a technology, it's called chips on pills. You can imagine, you have a stomach pain, you take a simple pill, and there's a very simple sensor on it that measures the acid level in your stomach. Makes sense. And you kind of transmit that to maybe a bandage you have on, and that is useful information when you have pain in your stomach. But you don't want the flyers of the pharmaceutical company showing up at your house a week later telling you, hey, by the way, we also found 20 other things. And you don't want to get somebody else to say, like, by the way, we happen to know your wife is French, which is true in my case. I'm just coming from France. So we know your wife is French. We assume you drink a lot of wine, so we put you on the liver transplant list for 20 years from now because you may need a new liver. Those are the kind of things where with data and big data, we need to be really careful. And what you see there, by the way, what's interesting, there are laws, different laws in different kinds of the world, but typically they're not enforced yet. The expectation is that it'll change, and then the business will have to follow. And things like big data in healthcare, we will have to be very careful with big data in healthcare. I'll leave it at that.
Thank you very much, Michael. Hi everybody, I'm Olaf Zimmerman. I spent most of my 20 years in IT, not in academia, but in industry, working for a system integrator, like the consulting business of IBM. So for the most part, Paul this morning has taken me out of the job in commenting application areas and value of big data and so on and so forth. So I'll comment a little on areas where I see gaps, both to make this vision a reality, but also concerns that I have and threats that I see. Some themes Michael talked about will come back. So as a systems integrator, for a couple of years I specialized on service-oriented architectures in this enterprise application development context, and one reaction I often got was, this is nothing new, SOA stands for same old architecture. I got that all the time when presenting and trying to get people excited. And I had a similar reaction this morning when I heard from Paul about this, the 4 V's, right? Volume, velocity, variety, and veracity. At least 3 of these, I would argue, we've been dealing with for decades, right? That's very much the same kind of challenges that we've had before and that we've partially solved. Like in enterprise application development, variety, different data formats and different data sources. That's a fact of life, right? That's really business as usual. If you look at, we have patterns, we have tools to deal with this, so nothing new there. Same for velocity, I would argue, like sub-second response time or millisecond response times. Nothing earth-shattering. The same for velocity and variety, veracity. That was also mentioned this morning. Do we believe in the data that we have? So that's a big topic in enterprise application development. Things like master data management. Both my previous employer and our host here, Microsoft, they have products and practices, right, to deal with master data and clean it up and cleanse it. So that's something we really need here too. And I was missing that in most of the presentations, as a matter of fact, right? Semantics of data, finding duplicates, right? To give you a simple example, I wrote a book 10 years ago on web services design and production experience with web services technology. And my name, Olaf Zimmerman, happens to be a very common name in Germany. If you just Google me, you find a carpenter that has this name, a radio DJ, and also a guy that publishes on a regular basis books for children. So when you hit this button, find more from this author on Amazon, I did that. I was really proud to see my book there online, right, in the bookstore. And I didn't realize I've also written these books, right? Lots of children's books came up. And in retrospect, when I hear now about analytics and what happens with this data, I'm really happy that this guy writes books for children and does not give advice how to create havoc in subway stations or other places in the world, right? So seriously, that's a big threat, right? That you are confused to be somebody else. So I'm really concerned about this. Maybe I should change my name. Anyway, so that was my reaction, my initial reaction, right? There's one big difference though, and that's in the volume, obviously, right? In big data. So here the internet comes into play, and our mobile phones that are happy to collect a lot of data about us, and this includes a lot of what the security people call SPI, right? Sensitive personal information. And John Howie made it very clear, right? How easy it is to bring, data from different sources together. And as a response to his presentation, I think I'll return my customer loyalty card from my supermarket when I'm back in Europe. So that's the big difference here. And this time, this means it's opportunity and threat at the same time, right? We can really succeed with the big data story and do a lot of high value, meaningful applications, but it's also a big risk from my point of view. I did make that point about semantics of data, right? And drawing the right connections and cleaning up the data, right? So I would argue that quality matters more than quantity. So maybe we need new roles, right? In the BI community, we had something like data stewards, business intelligence, right? Maybe we also need data quality managers here, or additional roles in not just data scientists, but also data engineers or information engineers that follow a repeatable process in defining the metadata that is still continues to be needed, right? No SQL is not a departure from SQL we heard this morning. It still has its place, metadata and data structures. So maybe we need additional roles, right? And hopefully the software engineering community can help here with some experience gained when establishing and defining these new roles. I did mention the human factor, that I'm a little concerned as a solution architect who builds enterprise applications. I'm excited. I'm thrilled about the additional opportunities to gather data and also present results of analytic algorithms to users. But as a consumer of these services and as an object that's monitored by these systems, I'm also a little concerned. So hopefully we can discuss this topic in the panel. Thank you.
Okay, my name is Magnus. I'm working for ABB. I'm heading the development center in India right now, which is quite a big change from moving from Sweden to India. But that doesn't have so much about big data to do. But anyway, I mean, in ABB, we're doing a lot of industrial systems that are mission critical, hard real time, etc. And a big property is, of course, integrity of the customer data. I mean, you can imagine if it's an industrial plant, a factory, we have a lot of sensors that are gathering data all the time. But the question here is a lot about ownership of data. It's a little bit like the medical case that Michael, you brought up. And I mean, the customers, our customers, they don't want to share the data because that's their proprietary data and their business data. So even if we could harvest the data, we are not allowed to. So we are prevented from really blocking out that our system cannot even collect the data. Even if technically it's possible, we are not allowed to do it. However, we do it in some cases, like we have in robotics, we have all the industrial robots are calling back and sharing their status, diagnostics data, etc. And that we have kind of solved the integrity problem, but still it's very hard to come up with the big solutions on really how to do the business model out of it. We can do some preventive diagnostics, so we can analyze the data and talk to the customers and say, hello, Mr. Customer, it seems to have a problem. So we call up them and send out some service technician before the problem occurs, which is very good. But take it to the next level is very hard because we really would like to integrate all the factories, etc. We also do products for the power grid, national power grids in the country, for instance. And that's also integrity. And back to Anita, you said defense. I mean, hacking. That is really a big challenge, the threats, etc. So apart from the ownership of the data and the integrity of the data, I think one thing is important that I haven't heard so far is that this perspective of time. Our systems and industrial systems sit in the field for a very long time. They can be 15 years, 20 years working in the system. So it's a big challenge would be, I think, how to version control the data and the structures of the data and keep the lifetime of the data structures, etc. Maybe, Olaf, you mentioned like the data engineer, and Jeremy pointed to the problem of the configuration problem in Google. I mean, how these different racks, different computers, different software. I mean, we will have the same challenge with data over time, that even if I have an algorithm today that works with these sets of sensors, etc., in the future there will be some new properties of these sensors, new analyzing version of the algorithms, etc. And how can we roll that out if there is a heterogeneous systems out there? I mean, you will have a mix of old versions of old systems with new systems, and they will not send the same structure of data. That will be, I think, a big challenge on data mining in the future. It's more or less easier if it's a public data, you can be on top of it, but I think, yeah, that's perspective of time is something I urge the community to look into a little bit more. Yeah, I think with that, Rafael, I hand over to you.
So thank you very much. First, thank Hakan for the opportunity and the invitation to be here in the panel. Although I'm not an expert in big data, I will, in my position at the university, I have the opportunity to manage or to help researchers look for opportunities in terms of research projects and try to get them connected with industry and government. So I happen to get in contact with many projects around big data. So to start, first, I think it's important to understand the context. So I'm from Brazil. I'm from a city called Porto Alegre in the very south. I'm a professor in the university. And Brazil is a very big country. We have 200 million people living in Brazil. And in the last years, Brazil has faced or is facing a boom in the IT industry. You might have heard something about many companies opening offices and development centers there, and many opportunities around IT. So what I was asked to share with you was my perspective about Brazil as an opportunity to have or to take the advantage of the data that is available. So, for example, from a government perspective, the government just launched last year a law. It's called the Transparency Law, which means that they will basically give access to all public information to everybody that want to know something about everything related to the government. So they will make the data available, and they develop a portal, a website called Transparency Portal, where everybody can go, access data, and maybe build something, build applications, and try to analyze what's going on in several areas of the government. Also, two or 3 months ago, a very famous magazine, not specifically for IT, had a cover story about big data and the opportunities for Brazil. So big data is, I would say, it's a buzzword now in Brazil. Everybody's talking about big data. But I agree with Paul, the keynote this morning, that it's not only the big data, but what we're going to do with the data that is available. So in terms of opportunities, in terms of Brazil, first is, of course, big data for government. We already have many people developing several applications to show data in terms of transit, data related to politicians, how they are performing, and so on, and data useful for the population, for people that lives in the cities. So I think the challenge here is how to transform the open data that the government makes available into smart data. So I think that's probably the key thing here. The other thing that we are seeing is the term smart cities is something that's calling the attention there. So my city, for example, Porto Alegre, is involved in the IBM. There's a program called the IBM Smart Cities Challenge. So there's going to be people there analyzing what can be done with the data that is available, and how to transform or how to improve the city to be a better city. And this will also be using the data that is available. Another interesting area of opportunity is in terms of oil production. Brazil, as a huge country, has some areas where you can explore and produce oil. But it's very hard to find the sites where the oil can be produced. So one of the companies called the EMC, you might know, of course, they established a research center there to develop technology to identify or to help to find those sites. So they are calling this big data for big oil. So that's an initiative that is going on right now there in the country. And interesting things, we have next year the World Cup, the Soccer World Cup. In 3 years we'll have the Olympics. And for this year we had the kind of a preparation, kind of the Soccer Confederations Cup, which was 2 months ago, I guess, or last month. So there was a company providing data based on the comments of the people, like using social media and so on. And this data, this big amount of data, were analyzed and sent to the coach and the national team for them to know what was happening in terms of how people were seeing the team after each game. In terms of competences, universities are starting to develop courses and programs in big data. I believe that the analytics part is the most important one. So that's probably the challenge that we have to work with. So several initiatives are in place. There are many opportunities. I agree with the privacy. You have to be very careful on what we're going to do with the data and how we're going to use the data. But I think that's it for now. So I hope we have an interesting discussion.